Welcome back to part 2 of Module 5, Factor Linear Expressions. We're picking this part up with an inquiry question that says, how can algebra tiles help you to factor linear expressions? And I'm kind of curious about this myself because I've never used algebra tiles to do this, so let's take a look at it. You can factor a linear expression by writing it as the greatest common factor of its terms and its remaining factors. Watch the video to see how to use algebra tiles to factor linear expressions. So I'll go full screen here.
Use algebra tiles to factor linear expressions. An x tile has a length of x and a width of 1, so it has an area of 1x, or x. A 1 tile has a length of 1 and a width of 1, so it has an area of 1. Use algebra tiles to factor 4x minus 8. To factor a linear expression, find the product of its factors. Place 4 x tiles and 8 negative 1 tiles on the mat. Arrange the tiles into a rectangle with equal rows and columns. The total area of the tiles represents the product, 4x minus 8. Its length and width represent the factors. The rectangle has a width of 4 1 tiles and a length of 1 x tile and 2 negative 1 tiles. So, 4x minus 8 equals 4 times x minus 2.
Alright, that's pretty cool. Well, alright, learn something every day. That's actually kind of neat how that works. Not that we're going to be using algebra tiles on the test or anything, but it's pretty cool to see how it actually works. So now they want us to use algebra tiles to model the expression 2x plus 6 on a map. Then arrange the tiles into a rectangle of equal rows and columns, and what expression represents the length and the width. So, well, let's see here. We've got 2x plus 6, so I'm going to need to get 2 x's, and I'm going to need to get 6 1's. And they said for us to take and stack them up so that they are in even rows. So there's an even row, here's an even row, here's an even row, and there's now 6 1's there. So our height is going to be 2, and our width is going to be x plus 3. So we would take and write that as an algebraic expression as 2 times, in parentheses, x plus 3. Are they going to give us a chance to do that? No, apparently not. That's kind of disappointing, actually. Now here's a new one. They want us to do 2x minus 8. So we're going to start off with our 2x's again. 1, 2. And then our minus 8. There's 2 of them. Here's 4 of them. Here's 6 of them, and here is 8 of them. So what do we have here? Our height is going to be 2, and our width is going to be x minus 8. So when you wrote your problem, I would do that as, let me show you what it would actually write out as. It would write it as, when we had it laid out there, you'd have a 2 here, you'd have an x minus 4 right there because you're too high, and x minus 4 wide, so you would rewrite that as 2 times, in parentheses, x minus 4, and that would be your final answer for that one. That's actually pretty dang cool. Sadly though, once again, they're not giving us any place to check our answers. Let's do another one, I think. Now we want to take and do 3x minus 6, so we're going to set it up with 1, 2, 3 x's. And minus 6, so we're going to do 1, 2, 3, 4, 5, 6. And let me just go ahead and take a picture of that, and that'll make it look a little better when we actually do the work, since they're not giving us a place to do that part. We'll come back over here, paste that in, and now when we write it in, come on baby, work for me. Work for me. You're not working for me. Let's try this again. There we go. When we write it in, what is the height of it going to be? Well, the height's going to be 1, 2, 3. You can see that here, 1, 2, 3. So the height is going to end up being 3. And the width is going to end up being x minus 2. Come on, baby. X minus 2. So our answer in factored form, quit that, would be 3 times x minus 2 in parentheses. And that's what the answer to that one would be. Pretty cool stuff. Alright, enough playing with toys. Now let's take and figure out how to do this using algebra stuff. You can use the distributive property and work backwards, to express a linear expression as a product of its factors. A linear expression is in factored form when it is expressed as a product of its factors. Vocab term. Let's watch their video.
To factor a linear expression, start by finding the greatest common factor, or GCF, of its terms. Write the prime factorization of each term.
Upside down division.
Then circle the common factors. Multiply the common factors to find the GCF. Next, write each term as a product of the GCF and its remaining factors. Then apply the distributive property. The factored form of the expression 12a plus 6b is 6 times the sum of 2a plus b.
Alright, they did a fair job of explaining that, but I think we can do a better job when we slow it down and actually talk about what's happening there. So the problem they give us is the factor 3x plus 9, and they're going to show us examples of how to work this, and then we're going to get to work it on our own. Now they're going to say first, factor each of the terms. So you're going to factor the 3x, and you're going to factor the 9, and when you do that, they're not really showing it to us here, but let's go ahead and show it anyhow. We're going to take a screenshot because I want you to see how they're coming up with these numbers. I hate it when they just throw down answers for y'all and then don't tell you how they got them. So, come on, computer. We're going to take and paste it in. Oh, that's not the one we wanted. It's been doing so good in pasting, and now it's giving me trouble. So we're going to paste in what they have here, and we're going to take and factor each of the terms. So factoring the 3x, that is going to end up being 3 times x. So 3x is equal to 3 times x. Factoring the 9, that's going to be 3 times 3. So we're going to take and say 9 is equal to 3 times 3. What do they have in common? That 1 3 right there. They're going to share a 3, so we're going to come back over here and we're going to say the greatest common factor. Well, that's going to be 3. Then what they did is they said, all right, let's take and multiply that 3 times what is left. So we're going to take the 3 that they shared, pull it out, and in parentheses we're going to put everything that's left. What is left right here? A positive x. What is left right here? A positive 3. Now, I think they're including another step in there where they said 3 times x plus 3 times 3, which would probably be a good thing for you to do as well. And then you can see where you pull out the 3's and you're left with the x plus 3 right here. Going back to the original problem up here, that's exactly what they did. They pulled out the 3's. 3x was equal to 3 times x. 9 was equal to 3 times 3. Then they factored out the 3, leaving the x plus 3 as the final answer. So I'm good with how they showed their work here, but you do need to show your upside down division here to indicate how you're finding your greatest common factor. Alright, now it's going to be your turn. Upside down division first. After you find your upside down division, circle the like terms, or the like factors, common factors. Pull those common factors out, set it up where it is a product of the common factor and everything that is left, and then pull it out the rest of the way, the common factor times in parentheses what's left there. And you would think with all this talking the computer would have given us the problem. Let me pause it. Well, I found out the issue. I lost internet for a minute, but now it's back. So you guys take a minute, pause the video, work this problem. Alright, I got my problem, 4x minus 28, and I'm going to take and just kind of maybe, if I can get things to work, there it goes, drag it over here, and I'm going to factor my two factors, or my two terms. 4x, that's going to be 2 goes into 4x, 2x times, 2 goes into 2x, x times, so 4x is going to equal to 2 times x. Meanwhile, 28, 2 goes into 28 14 times, 2 goes into 14 7 times, so 28 is going to equal to 2 times 7. What do they share? They share two 2's, so 2 times 2, that's going to end up giving me 4. 4 times what's left, well, up here is going to be 4 times the x that's right here, plus, and what's left on this one, that's going to be 4 times the 7 that is right there, and we can use parentheses so we're keeping it uniform. And the last thing we have to do is take that 4, pull it out, so it's going to go right there, and everything that's left goes in parentheses, x plus 7, and there's our final answer. 4 times the sum of x and 7. 4 parentheses, x plus 7, close my parentheses, check my answer. Well, there's a minus sign, not a plus sign. Pesky little signs got me in trouble here. Now we have the happy sound. Not a hard problem at all, but you do need to be showing your work the right way, and of course you need to be putting the proper signs in it as well. This is showing your work. This is what I must see. If I see anything else on each and every problem of your homework, yep, you've done it just for fun. Now we would be remiss if we didn't do at least one problem with fractions, because fractions are really important things and you're going to have to carry them all the way through high school, and those of you that go on to college, yep, you're going to be working fractions there too. So with that in mind, let's take out this one, 1/4 x plus 1/4, which is super easy, by the way, because the common factor is just obvious there. If you take a look, 1/4 x and times plus 1/4, the common factor is 1/4. Okay, guys? I mean, it's there in your face. So 1/4 x, that's 1/4 times x. 1/4 is 1/4 times 1. That's the catch on this one. Recognizing that the 1/4 is equal to your 1/4 times 1. Let's make that a little bit bigger here. From there, we're going to pull the 1/4 out, put them in front, and in parentheses, the x plus the 1. So your answer, 1/4, is times the sum of x and 1. That's all there is to do in these. And now it's going to be your turn. Pause the video, solve the problem, and then find out which one of these is going to be the answer. Go ahead and do that now. Did you get it done? Let's take a look at how we're going to work this one. We're going to go ahead and break this one down. Once again, the common factor, extremely obvious in this one, is going to be the 3/8. So the first part is going to be 3/8 times x, plus the second part, this is a trick here, 3/8 times the 1. We're going to take the 3/8, we're going to pull them out to the front. That means our pizza's done, just in time for dinner here. We're about to finish this lesson. And then we're going to take what's left, the x plus the 1, and right there is going to be your final answer. 3/8 times the sum of x and 1, which B works for that one. It can be factored, and yep, B's the only correct answer. We got the happy check mark there. And with that, I think we're going to finish this lesson. In fact, we're on resource 16 of 16, which means they didn't even give us an apply problem. Yay, because I really don't like reply problems. You all get busy on your homework. I'll look forward to answering any questions you have in class tomorrow.